In this video, we'll continue with chapter 6, and now we will be majorly focusing on molecular compounds. So we saw previous video that compounds can be divided into ionic compounds which contain ionic bonds, and these bonds are usually formed when it consists of a metal and a non-metal bonded together. Whereas in case of molecular compounds, they always consist of non-metals. So basically two non-metals or more than two non-metals interact with each other to form molecular compounds. The type of bond that these compounds usually consist of are called covalent bond, which are formed by sharing of electrons. These molecular compounds also have some attractive forces. We'll talk about those in another video, but basically they also have, along with the covalent bond, they also consist of some attractive forces, which can be either dipole, hydrogen bond, or dispersion forces, and this depends on which molecule we are talking about or which compound we are talking about. Okay, so in this video, we'll basically just focus on what are molecular compounds, how to name them, how to identify them, how to write their formula if we know their name. Alright, so by definition, molecular compounds are the ones that consist of two or more non-metals that can attain a stable electronic configuration by sharing of electrons. So how do we write the name and formula for molecular compound? Basically, the rule is that when we are naming a molecular compound, the first non-metal in the formula is named by the element name. So whatever is the name of the first non-metal that we see, we basically just use the name of it element. And the second non-metal is named by using the first syllable of the name followed by IDE. Okay, and whenever there is a subscript present in the formula, that basically tells us what is the number of atoms present in the element. And to show how many number of atoms are present, we basically use a prefix in front of its name. Prefix means, let's say if there is one atom present, we use the name mono. If it's two atoms, di, three atoms, tri, four atoms, tetra, five atoms, penta, 6 atoms hexa, 7 atoms hepta, 8 atoms octa, 9 atoms nona, and 10 atoms deca. For instance, we can take an example of one of the compounds. Let's say if I'm working with NO. Okay, so this is a molecular compound. How do I know that? First thing, I need to identify that N is a non-metal, oxygen is also a non-metal, which means this is a molecular compound. And how do we name the molecular compound? We are going to follow these two rules that are given to us. The first non-metal that is written in the formula is nitrogen. So we basically just use the name of the element. So it will be written as nitrogen, followed by the name of the second non-metal with ending with IDE. So this will be oxide. Now the subscripts that we see here, we have to also tell what are those subscripts. So what is the, if there is no subscript written, that essentially means this is 1. So you can assume NO means N1 and O1. Usually whenever the number of atom is 1, we usually skip the writing the number 1. But that essentially means it's one atom of nitrogen, one atom of oxygen. So for 1, we use a prefix mono. So if you were to put here a prefix, that would be mono. So you would think it would be mononitrogen monoxide, right? But ideally, whenever we are writing the name, you would never see the name to begin with mono. So whenever, even though it is mono, if there's one atom in the first element, you would never use the prefix mono in the very beginning. So even if it is one atom, you can basically just get rid of mono. But if it is 2, 3, 4, any other numbers, you would still keep the prefix on. Only prefix that we never use in the beginning of the name of the first element is mono. So final name of this compound is going to be nitrogen monoxide. And here, since it's like two O's, you basically can get rid of one of these and use monoxide. Let's try naming a couple other compounds. Let's say if we are working with this, what would be the name of this compound? First thing, you should identify if it's molecular or ionic. So carbon is a non-metal, oxygen is a non-metal, meaning both are non-metal, so this is a molecular compound. And these are the rules that we use to name molecular compounds. So what is the name of the first element? First non-metal is carbon, so the name would be carbon. How many of these? Just one, so mono. We will be skipping the mono in the beginning. The next second element is oxygen, so the name would be oxide. But oops. So name would be here oxide, because the name second and non-metal ends with ite. And how many of those do we have? Oh, never mind, this is going to be carbon dioxide. Okay, now if we were to name this compound, which is CO, we'll name the first element, which is carbon, followed by the second element, which is oxide. And how many of carbons? Carbon is one, but we never put mono in the beginning, so that is going to stay as it is. How about this oxygen? This oxygen would be oxide, and we have one of those, so it would be monoxide. So carbon can be carbon dioxide, carbon monoxide. Right. Okay, moving on, let's. Okay, so this table gives you examples for a bunch of different molecular compounds that you can practice naming. So what I would suggest is you basically look at the formula and come up with their names on your own without looking at the answers here, and do the reverse as well. So look at the name of the compound and then try to come up with for the chemical formula for that compound. Let's try a couple questions. For instance, if I'm looking what would be the chemical formula for this compound, it is called carbon disulfide. So when you look at the name from here, you can basically tell that this is an example of molecular compound. Why? Because we only use these prefixes in case of molecular compounds. Secondly, you can also see that the carbon and sulfide both are non-metal in nature, meaning these are molecular compounds. Now to write the name, you basically write the first element, which is carbon, so that comes first. Then it is disulfide, meaning we have two. Sulfide stands for sulfur, which means we have two of those, so whatever is the prefix, that would become your subscript in the molecular formula. So the molecular formula here would be CS2. Carbon dioxide, we first write the name of the first non-metal, which is carbon. And how many of these we have? No number is given, meaning it's one. Dioxide means there are two oxygen atoms, so O2. Whatever is your prefix will become your subscript in the molecular formula. And when you're doing the reverse, so if you're going from formula to name, whatever is your subscript, that becomes your prefix for the name. So you see right here, nitrogen, NO, we just wrote this name in the previous slide. We wrote it as nitrogen monoxide. So my advice is that you stick with using the prefix mono. Sometimes you'll see that mono is not used that much, which is all right. Sometimes people skip those, but in my suggestion, you should stick to the rule and just put monoxide. Both of those would be acceptable. Okay. Let's try writing the name for this particular compound. This is N2O. So we'll write the name of the first non-metal, which is nitrogen. How many of those do we have? Two nitrogen. So it would be di-nitrogen. And then is the oxygen element. Oxygen will turn into oxide. How many of those do we have? Nothing's written, meaning I only have one. So it would be dinitrogen monoxide. So basically, you can see right here, the table tells you it's dinitrogen oxide, which is also all right, but I would suggest you stick to the rule. If it's mono, you just use the mono. And remember, we'd never use mono in front of the name starting. None of the names you will see will start with mono. Okay. You can try this question. What is this? This is, if you just look at the formula, it is sulfur. How many? One. So there's no prefix. And then we have fluorine. and here we have 6 of fluorines, so it would turn, the prefix would be hexa because it is 6, and fluorine will turn into fluoride. So the name would be sulfur hexafluoride. Now if we were doing the reverse, if the name was given and we were to go to the formula, sulfur would be S, fluoride would be F. How many of fluoride? 6. So formula would be SF6. So writing the naming and writing the formula of molecular compounds is a lot easier. Okay. Okay, we can try one more question. So here the question is, can you name the molecular compound B2O3? So B here is a, the question tells you here it's a molecular compound, but that's not going to be case in most of the times. Formula would be given to you as B2O3. You have to identify that boron is a non-metal, oxygen is also a non-metal, meaning this is molecular compound. Now for molecular compound, we name the first non-metal, which is boron. How many borons do we have? 2. So this would be di-boron, followed by the second non-metal, which is oxygen, and oxygen will turn into oxide. How many? We have 3 of those, so this would be trioxide. So the final name would be diboron trioxide for this particular compound. Another study check question is, write the molecular formula for diphosphorus pentoxide. So first, when you see this formula, you know this is a molecular compound. Why? Because you're seeing these prefixes written and you never see prefixes written in ionic compounds. So what would be the formula here? We'll start with phosphorus. Phosphorus is P. How many? Di, meaning we have 2 of those. So whatever is your prefix will turn into your subscript. Next we have oxide. Oxide basically stands for oxygen. How many of oxides? We have pent. Pent means it's 5, so that would turn into your prefix. So molecular formula here would be P2O5. So this is all about naming molecular compounds. This is the easiest type of questions that you can get from molecular compounds, naming of molecular compounds. Okay, the next thing we'll see is how you can actually identify if a compound is ionic or it is a covalent compound. So we have already seen ionic basically means it will consist of a metal and a non-metal, or it will consist of a polyatomic ion, which is like ammonia. Okay, so whenever you see ionic compounds, they will always consist of a metal and a non-metal, or instead of a metal, it will consist of polyatomic ion, which is ammonium ion, no other ions. Then we have covalent compound. Covalent compound basically means molecular compound where only elements that would be present would be non-metals. So you can identify if an element, if a compound is ionic or covalent based on this. If the first element is metal or ammonium, it's ionic. If the first element is non-metal, it is covalent. So here are some questions. The question is essentially, identify each compound as ionic or covalent and give its correct name. So let's start with the first one, which is SO3. How can we identify which compound this is? You look at the first element. In this case, the first element is sulfur, which we know is a non-metal, which means this is an example of a covalent compound. You can also identify that this is also non-metal, the second one is also a non-metal. So this is a covalent compound or a molecular compound. The bond A here is covalent bond. Now the next thing is name of this compound. So we start with naming the first non-metal, which is sulfur. How many of those? 1. So if it is 1, we do not use the prefix mono in the very beginning. So we'll start with sulfur, followed by the name of the second non-metal, which is oxygen. Oxygen will turn into oxide, so it would be oxide. How many of those? 3. So the prefix would be trioxide. Okay, the next compound that we see is BaCl2. Which type of compound it is? Ba is an example of a metal. How do I know that? If you look up Ba in your periodic table, you will see that Ba is present in the second group in your periodic table. This is barium. If it's present in the left side of the periodic table, it is a metal. Whenever it's a metal, the compound is ionic. This is a metal followed by a non-metal. How do we name ionic compounds? You simply write name of the metal, which is barium, followed by name of the anion, which is chloride. So instead of chlorine, again you use the first syllable followed by IDE. If this was a type 2 metal, we would be using Roman numerals in between, but since this barium is a type 1 metal, we can predict its charge. We will not be using any Roman numerals in between. So the name is going to be simply barium chloride. How about this? What you see right here is NH4. What is NH4? NH4 is ammonium ion. So whenever you see NH4, that essentially means this is an ion. So the compound has to be ionic. Okay. If you have memorized the polyatomic ions, you would be able to recognize that PO3 is phosphite ion and NH4 is ammonium ion. Here again, we do not care about this number that we see or the subscript that we see, because this is ionic. How do you name ionic compounds with polyatomic ions? You basically write the name of the first cation, which is ammonium, so it would be ammonium, followed by name of the second anion, which is phosphate in this case. So the phosphite, PO3 is phosphite, so name would be ammonium phosphite. Okay, moving on, we see this compound, which is Cu2CO3. What is Cu? Cu is an example of a metal for sure. Cu stands for copper. Copper is a metal. So this compound is also ionic in nature. What is the name of this? Again, you start with the name of the metal followed by name of the second ion, which in this case is anion. This is called CO3. CO3 2 minus is always carbonate ion. But first thing we have to see, if I'm writing the name copper, copper is a type 2 metal, which means I need to give its charge in parentheses. So we have to figure out what is the charge on this copper. How would we figure that out? Let's do this right here. So copper 2 plus mean CuCO3, Cu2CO3. So we first need to identify that this is copper. If we have two of those, that means let's assume the charge of each copper is X, and we have two of those, so the total charge would be 2x. What is the charge of this anion? Remember, this everything goes together. This is CO3 2 minus. So carbonate ion usually carries a charge of -2. How many of those do we have? We only have one. So that would be a total charge of -2 will be equal to 0, because the total charge on the compound is 0. So if you don't understand this, then basically that means you need to go back and review the video which is on ionic compound. So that would be the video right before this, video number 1 for naming ionic compounds. Anyways, moving forward, if I'm trying to solve for x here, this would give me 2x plus minus means a negative. 2 will be equal to 0. So in order to get rid of this -2, I will add 2 right here, add 2 on the other side of the equal as well. This and this will get cancelled to give me 0. What I'm left with is 2x is equal to 2. Now to get rid of this 2, I need to divide both the sides by 2. That would give me x as -1. So in this case, that means the charge on each of these copper is -1. So we will put 1 right here. Copper would carry, oh, did I put negative? Sorry, I meant positive. Copper would carry a charge of +1. Metals never carry a negative charge, okay? My bad. This would be +2 divided by 2 would give you a +1. What would be the name of the other ion here? We just said this is carbonate, so it would be followed by carbonate ion. So the name would be copper 1 carbonate. Do not forget to put this in the Roman numerals, otherwise your answer would be incomplete and not correct. Okay, next we see this molecule N2O4. The first element that we see here is nitrogen, which is a non-metal, meaning this compound is covalent. How do we name it? If it's a covalent compound, it's a molecular compound, we start with naming the first non-metal, which is nitrogen. How many? 2. 2 means dinitrogen. Followed by the next non-metal, which is oxygen. So oxygen would be oxide. How many? 4. 4 means the prefix is tetra for 4, so tetra oxide. So the name would be dinitrogen tetraoxide. Another thing is, whenever you see alphabet written like this, A and O coming together, so if two vowels are coming together, you basically get rid of the A and it would turn into tetroxide. So this would be dinitrogen tetroxide. So if you ever see two vowels coming together, A and O, you basically get rid of the A and you continue with the O. Alright, so I think this is the end of this particular video. This gives you information of how to name molecular compounds and how to write the chemical formula for molecular compounds.